So if you change the dimension of a shape, say the sides get twice as big, what's going to happen to the perimeters and what's going to happen to the areas? Will the perimeter be twice as big? Will it be 4 times as big? Will it be half as big? Will the area be twice as big, 4 times as big, half as big? There is an easy way to figure out, and you don't have to know all the dimensions. You don't have to actually calculate. All you have to know is what happened to the sides. And based off of that, you can find out what happens to the perimeters and what happens to the areas, and you don't even have to know the whole shape. You just know what the original measurement was. So let's do some investigation here. If you look at figure A, the dimensions of figure A are 2 by 3. The perimeter, remember how to find the perimeter, it would be 2 times 2 and 2 times 3. So the perimeter would be 10. And the area of that shape would be base times height, which would be 2 times 3, so the area is 6. So now let's look what happens. So it says figure B has double the dimensions of figure A. So if we just take each of the pieces, double 2, so those are 4 and 4, and double 6 would make it 6 and 6. So now my dimensions are 4 by 6. So let's look at what happened to our perimeter. Well, if we add 8 and 12, then our perimeter is 20, and our area is 24. So figure C, it says, has tripled the dimensions from figure A. So let's go back to figure A and let's triple it. So 2 times 3 is 6, and 3 times 3 is 9. So now my dimensions are 6 by 9. My perimeter is 12 plus 18, which is 30. And my area is 9 times 6, which is 54. So let's look at what the relationship is between those. So the scale factor from figure A to figure B. So if you looked at just your width to your width, so we would have from figure A to figure B, it would be 2 over 4, which is 1/2, or you could do 3 over 6, which is also 1/2. So the scale factor would be 1/2. A is half as big as B. What is the ratio of the perimeters? So let's look at our perimeters. So we did A over B, so we did 10 over 20, which is also 1/2. And then we did the ratio of our areas. Let's look, that would be 6 over 24. Let's reduce that down to 1 over 4. So that's kind of interesting. We notice that our sides and our perimeter have the same ratio, and then our area is different. So let's see if there's a pattern here. Let's do our scale factor of figure A to figure C. We lost our blank there. Figure A to figure C. So figure A would be 2 over 6, which is 1/3. Or you could do 3 over 9, which is also 1/3. But remember we said C was 3 times bigger, so A is 1/3 of it. Then the ratio of our perimeters, it would be perimeter of 10 over perimeter of 30, which reduces to 1/3. And then we have the ratio of our areas. Our area was 6 over 54. Let's reduce that. We get 1 over 9. So again, that's kind of interesting. I noticed that my scale factor and my perimeters have the same ratio. And then I notice that my area is different. And here's what I notice. I notice that my sides, so I noticed that I could take 1/2, and if I squared it, I got 1/4. And I noticed that I could take this 1/3, right? It was 1/2, and then I squared it, and I got 1/4. And I took 1/3, and I squared it, and I got 1/9, which makes sense because area is in units squared. So if I squared the area, then if I squared the sides, then I got the area. Okay, so here's our basic idea, that if my sides have a ratio of A to B, then my or A over B, then my perimeters will have that same ratio, A to B. Whatever happens to the sides happens to the perimeters. So if my sides get doubled, then my perimeters will get doubled. If my sides get tripled, then my perimeter will get tripled. My area, whatever happened to my sides, will be squared. So if my sides were times 2, then my area will be times 2 squared, or they'll be times 4. If my sides were times 3, then my area will be times 3 squared, which is times 9, and so on. Okay, so we have our pattern. So let's see if we can apply that to some shapes. So find the ratios of the perimeters and the areas of each of the figures below. Well, we found out that whatever the ratio of the sides is, that's going to be the ratio of the perimeters. And if we square that, that gives us the ratio of the areas. So my sides here are in a ratio of 4 to 8. So my sides are in a ratio of 4 to 8, which is 1/2. Then that means my perimeter will be in a ratio of 1/2, and my area will be 1/2 squared, which is 1/4. So that's what it's asking for right there. So let's do the same thing with number 2. So my sides are in a ratio of 9 to 12. Always reduce. Reduce those so that you can deal with the easiest versions of your numbers. That reduces to 3/4. That means my perimeter is going to be in a ratio of 3/4. And my area will be 3/4 squared, which is 9/16. Okay, same pattern. My sides are in a ratio of 12 to 5. Let me stay in the same left over right, 12 to 5. So that's my sides. My perimeter will have that same ratio. 12 over 5 doesn't reduce. So my area will have a ratio of 12 over 5 squared, which is 144 over 25. So it says 2 figures in each pair are similar. The area of one figure is given. Find the area of the other figure to the nearest whole number. So if I want to know area, that means I need to square what happens to the sides. So first let's figure out what happens to the sides. So I'm going to do my large side over my small side. Large over small. So you just kind of remember, large over small. Well, that reduces to 3 over 1. So if my sides were 3 over 1, then my area will be 3 over 1 squared. Because I asked for area, so I need to know what happens to the area. So that's 9 over 1. So if the ratio is 9 over 1, then what happens when the area is 100? So we just set up our proportion. So we have 100 divided by 9. And we get that the original area was 11.1, or 11, because it said to round to the nearest whole number. So when my sides were 1/3 as big, notice I didn't even care that it was a pentagon. I didn't even care what shape it was. All I cared about it was what was the ratio. So my sides were in a ratio of 3 to 1. That means my area will be in a ratio of 9 to 1. So, and it was large over small. So that's why I put it was large over small area ratio, large over small area ratio. Okay, we do the same thing here. Let's find the ratio of our sides. So the ratio of our sides was 10 over 25, which is 2 over 5. That's my side ratio. I'm asking about area, so I need to convert that to an area ratio. Well, if I square that area ratio, then I get 4 over 25. Okay, that was small over large, small over large. So I say small over large is equal to small, because I have the large ratio, small over large. So 4 times 500 divided by 25. And you get that the large or the small area has to be 80. See, the large one has 500 if it helps put it there. But you have to compare sides with sides, perimeters with perimeters, and area with area. Okay, so you had to convert it into, you had to square it to get the perimeter, or to get the area ratio. So in number 6, I've given you 2 pentagons that have areas of 50 to 162, and I want to know the scale factor and the ratio. So we have to go backwards. So in this case, I know the area is 50 over 162. Well, let's reduce that. I don't want to deal with numbers like that. Well, that's 25 over 81. Well, remember when we knew the sides, if we go back to number 1, if I knew the sides, then I knew the perimeter, and if I squared it, I could find the area. So if I'm starting with the area, let's work backwards. If I square root, the square root of 25 is 5, the square root of 81 is 9. So the scale factor and the perimeters would have a ratio of 5/9. We do the same thing here. They have an area ratio of 8/98. Let's reduce where we can. That gives me 4/49. So these are areas. Remember when we got to the area, we squared to get to the area. So let's unsquare to get back to the sides. So we unsquare by taking the square root. That gives me 2/7. So the scale factor is 2/7, and the ratio of the perimeters is 2/7 because the sides and the perimeter share the same ratio. The area is the ratio squared. And so we can determine without knowing, we didn't have to even find the whole area of the figure. We just had to know one of them. We didn't have to recalculate it. We could just use the pattern of the scale factor and the perimeter and the areas to determine what